Okay, today on geometry we're going to take a look at some problems from section 6.1. To start us off, we have problem, let's see here, it's 6.1 number 5. And we have three parts to this problem. And in each part we're asked to show proportionality. For A, we're given the ratio 11 divided by 24 is equal to 66 over 144. And what we're looking for is some value such that we multiply one side of the equation by, we get the other side of the equation. And in this case, let's take a look at 11 times 6. That's 66. So I take 11, I multiply it by 6, I get 66. The problem is it the same for the denominator? What happens when I take 24 and I multiply that by 6? Well, I get 144. So that means that I take the denominator, I multiply it by 6, I get to the denominator of the right hand side. 6, 6. It matches. They're both 6, so we've shown that this is a proportion. B, we have 14x to 91x is equal to 4 to 26. I'm not a fan of the colons, but they still do describe this. A youth spent building model planes and cars and robots and everything, and I can tell you that this sort of colon format is very common for showing scale for models. So let's see if we can show that these are proportionate. I'm going to take a look at the left hand side here. This first number is 14x, so 14x. I need to transform that into 4, so we'll set it equal to 4. And let's see here, I take 14 and I divide it, or excuse me, if I take 4 and I divide it by 14, not only that, but I divide by 14x, then I multiply that by there, I'm going to get 4. So let's see if that's true. Let's take 91x, multiply it by by our guess here, this, and we're going to take that, put it in there, and we'll see what we get. 14x, 4 divided by 14x. X's will cancel out, and we'll actually be left with 91 times 2 over 7. 7 goes into 91 13 times, so it's 13 times 2. We're left with 26. So the number that we were looking for was 4 divided by 14x right here. This is what we're looking for. We multiply both parts of this side by that, and we get to our new values on the right hand side. So these are proportionate as well. Found the constant of proportionality between the two sets. Finally, we're going to take a look at part C here. Part C has 3.8 to 9.5 is equal to 26.6 to 66.5. Okay, so I want to see what factor we multiplied 3.8 by to get to 26. So I'm going to take 26.6, divide it by 3.8. The important thing with proportionality is that you always want to work with exact numbers. Don't represent things in terms of decimals. Let's see, if I take 9.5 and multiply it by 7, I get 66.5. Well then, why is it that these guys are decimals? Well, they're still exact values. They're not approximate. If I took 7 and divided it by 3 and wrote that as a decimal, that would be an approximation. If I said it's 2.3 exactly, not an approximation. That's the big difference there. So these values are not approximations. Similar to how I said 2/7, that's not an approximation. That's the exact value. 3.8, not an approximation, the exact value. Okay, now let's go ahead and let's take a look at a few more problems. I want to take a look at number 30 now. And we're asked to prove, so our proposition is A plus B divided by B is equal to C plus D divided by D, and that implies that AB is equal to CD. I smell something fishy here. Take a look at this. I've got plus B, my denominator is B, plus D, my denominator is D. So I want to take a look at what's going on in that fraction. A plus B divided by B. I can distribute the division into the numerator there. So it's A divided by B plus B divided by B. That's A divided by B plus 1. Likewise, C plus D divided by D, I can distribute C divided by D plus D divided by D. I get C divided by D plus 1. Okay, now remember, we did have that this was equal to this. That was the start of this whole thing. So we're just going to go ahead and set these guys equal to each other. A divided by B plus 1 is equal to C divided by D plus 1. Each side has 1 added to it. So I got 1 here, I got 1 here. I just subtract 1 from both sides, and I'm left with A divided by B is equal to C divided by D. And we're done. So to show this, we just need to use a little bit of algebra. We need to distribute the division into the numerator. Instead of AB divided by B, we took and we distributed that B, and we were left with 2 separate divisions here. And this addition went from inside these parentheses in the numerator to outside. Useful trick. And since these two right here, these extreme left values were equal to each other, and that was this part, we were able to set the extreme right values equal to each other. The next example is a little bit different. We're going to take a look at number 34. Proposition there is another proof. If A divided by B is equal to A plus C divided by B plus D, then AB is equal to C divided by D. Proof. We'll cut straight to the chase here. So there's a nice little theorem. Theorem 6.1 in the textbook that talks about how if you cross multiply, that shows proportionality. So what we're going to do is we're going to take A, multiply it by BD, then we're going to take B, multiply it by AC. It's called the cross multiplication theorem. And as you can see here, this is just simply BD multiplied over through here. And this is AC multiplied down through the denominator. And if you fiddle around with the division, you can show that this expresses the same thing as the fraction, just in a different form. Okay, so let's take and we'll distribute. We'll end up with AB plus AD is equal to AB plus BC. Hey, AB, AB. These guys are going to cancel out. What are we going to be left with? We're going to be left with AD is equal to BC after we subtract AB from both sides. And this is, again, Theorem 6.1. Theorem 6.1 is bijective. It says not only if they are proportionate, if the fractions are proportionate here, you can express it in terms of multiplication, but it also says that if the multiplication is true, if this line is true here, then that implies that A divided by B is equal to C divided by D. You divide both sides of the equation. We'll take a look here. I'm going to divide the equation by D. These D's cancel. I'm left with A is equal to BC over D. Then I divide both sides of the equation by B. These B's cancel, and I'm left with AB is equal to CD. Just what I wanted. So yeah, we hit that. That's what we wanted to show. We're done. We had to use Theorem 6.1 twice. And it's important to use those theorems and make sure that you get a good understanding of what proportionality is for this section. Alright, thank you, and until next time, happy geometering.